Good afternoon, students. Welcome back to chemistry class. Today we are going to study about shapes of atomic orbitals. Shapes of atomic orbitals. What do you mean by orbital? For better understanding this orbital concept, let's take an example of ceiling fan. If you see the ceiling fan, so it will be entirely cover the central, but when this ceiling fan will slows down or it will be stop, in that condition it will occupy only certain position of the circle. That position are known as orbital. Okay. So what do you mean by orbital? Orbital means the three-dimensional space in which the probability of finding electron is maximum. Okay, that means the place in which the probability means possibility of finding an electron is maximum. Understood? According to Heisenberg uncertainty principle, it states that it is impossible to find out the position of an electron in an atom. Based on Heisenberg uncertainty principle and dual nature of an electron, the new quantum mechanical model is developed, okay, by Erwin Schrödinger. Who developed the new quantum mechanical model? It is developed by Erwin Schrödinger. The solution of Schrödinger wave equation. What about the Schrödinger wave equation? We studied about that. Schrödinger wave equation means dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi is equal to 0. This is the Schrödinger wave equation. From the solution of Schrödinger wave equation, we get the value of psi. Okay. From the value of psi square, the probability of the different points within an atom, it is possible to predict the region around the nucleus where electron will most probably found. Okay. A large number of orbitals are possible in an atom. These orbitals can be distinguished by their size, shape, and orientation. Okay. Atomic orbitals are distinguished by the quantum numbers. Each orbital is designated by 3 quantum numbers. What about 3 quantum numbers? Principal quantum numbers, azimuthal quantum numbers, magnetic quantum numbers. Okay, and after that one quantum numbers having what is the spin quantum number. Spin quantum number only represents the spinning of electron in an orbit. Spinning of electron within orbit. Okay, others 3 quantum numbers represents the shape, orientation, and energy levels of the orbitals. Okay, the principal quantum number denoted by the symbol small n, it represents the various energy level in the orbital. Okay, second, the azimuthal quantum number, otherwise known as angular quantum number, it is denoted by the symbol small l. It represents the shape of the atomic orbitals. Another one, magnetic quantum number, it is denoted by the symbol small m. It represents the orientation of an orbital. Okay, when n is equal to 1, whatever the principal quantum number value, 1, 2, 3, 4, the n is equal to 1 means L is equal to 0, it represents the s orbital. Okay, when n is equal to 2 means L is equal to 0 and 1, it represents the p orbital. Okay, 0 represents s orbital, p represents 1 represents the p orbital. Okay, when n is equal to 3 means whatever shapes are having here, 3 shapes. What are they? 0, 1 and 2. Okay, 0, it will be represents the s, p and d orbitals. Okay, when n is equal to 4, n is equal to 4 means whatever shapes are having here, l is equal to 0, 1, 2, 3. 0 represents s orbital, 1 represents p orbital, 2 represents d orbital and 3 represents f orbital. Already we studied about that clearly. Okay, I hope all of you know about that. Now we are going to study about the shape of the atomic orbitals. The atomic orbitals differ in shape. That is, the electrons they describe having different probability distribution. Different probability distribution around the nucleus. The atomic orbitals differ in shape. Okay. That is, the electrons they describe having different probability distribution. That is why the electrons, different shapes of the orbitals are having. Okay. What are the orbitals are having? S orbital, p orbital, d orbital and f orbital. What is the shape of the s orbital? S orbital spherical in shape, d orbital dumbbell shape, d orbital clever leaf shape and f orbital shape. The f orbital, it is very complex shape, so it is not required right now. Okay, and so today we are going to study about only shape of the s orbital. Okay, after that the p, d, f, after that we can study. For s orbital, when n is equal to 1, L is equal to 0, the value of m is equal to 0. Okay, value of m is 0. L is equal to 0 means the m magnetic quantum number, it represents the 0. Okay, only one orientation. M means magnetic quantum number, it represents the orientation of an orbitals. For L is equal to 0, that is s orbital, only one orientation there, value is 0. Okay, that is only one possible orientation having here, only one possible orientation. This means that the probability of finding electron is same in all direction at given distance from the nucleus. Okay, s orbital, only one possible orientation. This means that the probability of finding an electron is same in all direction at a given distance from the nucleus. Okay, you see these are the s orbital. This s orbital, the probability of finding electron is same, okay, in all direction at a given distance from the nucleus. Okay, it should therefore the spherical in shape. Hence, s orbital are non-directional and spherically symmetrical about the nucleus. Okay, then greater the value of n, larger is the size of the orbital. When shape of the n orbit, greater the value of n means principal quantum number. When the value of n increases, the shape of the s orbital will be increases. Okay, the shape of the s orbital will be increases. When n is equal to 1 means 1s orbital, this is the 1s orbital. N is equal to 2 means 2s orbital. Okay, you see this is the 2s orbital. When n is equal to 3 means 3s orbital. When n is equal to 4 means 4s orbital. Okay, when greater the value of n, size of the s orbital increases. Okay, see here, this is 1s orbital. When compared to 2s orbital, this is 1s orbital. When compared to 1s orbital, 2s orbital size increases. Okay, when compared to 2s orbital, 3s orbital size increases. Okay, when compared to 3s orbital, 4s orbital size increases. Okay, understood? This is the orbital size. Okay, so understood clearly. Remember that the size of the s orbital, it is spherical in shape. Okay, size of the s orbital is spherical in shape. Understood? Okay, now let us discuss about the shape of the s orbital in one electron system. There is like hydrogen atom only one electron can represented in the form of spherical polar coordinates. Okay, the shape of the shape of the s orbital in one electron system, shape of the s orbital in one electron system like hydrogen atom can represented in the form of spherical polar coordinates. Okay, what are spherical polar coordinates? R, theta and psi. Phi. Okay, the shape of the s orbital in one electron system like hydrogen atom can represented in the form of spherical polar coordinates that are small r, theta and phi. Here r means the distance. Okay, r means the distance between the nucleus and the electron. Okay, consider they're having the electron, the distance between consider the one of the s orbital. This is the nucleus. Okay, so r means the distance from the nucleus and the electron. Here the probability of electron is maximum. So r means the distance between the nucleus and the probability of electrons. Okay, and then theta. Consider one of the orbital, s orbital. This is the nucleus. This is the probability of electron, spherical in shape. Okay, r means distance from here to here, there is r. And about the orbitals are three-dimensional space. The three-dimensional space we can mention here x, y and z. Okay, x, y and z direction. Here or the distance between the center of the nucleus and the maximum probability of electron, that is called r. And theta, what do you mean by theta? Theta means the angle between the z-axis and the r. Distance between z-axis and r, that is called theta. And then phi, what do you mean by phi? Means the angle between the x-axis and r. Angle between x-axis and r, that is called phi. Okay. So one substance is in 3D region, three-dimensional region. There is r, theta and phi having. Okay, well, one of the substance having in 3D region. Here have the three polar coordinates are having here r, theta and psi. Okay, there is we can find from the wave function, Schrodinger equation, Schrodinger wave function. So one of the three-dimensional region, the psi, the polar psi into r, theta and phi. Okay, is equal to, we can write these polar coordinates as function. So we get r into r, f into theta and g into xi. Okay, here r into r, that is called a radial wave function. There is distance, it indicates the radial wave function, that is the distance, radial wave function. And f theta and g phi that represents the angular wave function. Understood? The radial wave function, there is r. It represents the distance from the nucleus and the electrons. Remaining two functions that f theta and g phi denotes the angle. Okay, so it is represents the angular wave function. Okay, understood? The r, it represents r into r, it represents the radial wave function, and f into theta and g into phi, it represents the angle. So it represents the angular wave function. As we know, psi, it is one of the mathematical expression, but it is not having any physical meaning, physical significance. But when we are taking the square of psi square, from that we can find out the probability of finding electrons is maximum. Okay, the psi from the Schrodinger wave equation, we get the psi, the value of psi, that is wave function. Okay, the psi means it is not having any physical meaning, but when we are taking the square of psi, we can find out the maximum probability of electrons. Okay, maximum probability of electrons, because the electrons, the electrons revolve around the nucleus very fastly. We cannot find the exact position of an electron, but when we are taking the square of psi square, the value of wave function, when we are taking square of psi square, we can predict the maximum probability, that is 95% probability of electrons with given volume of space. Okay, let us analyze how psi square varies with the distance from the nucleus and the direction from the nucleus. Okay, let us analyze how psi square, there is wave function, that is vary with the distance from the nucleus and the direction from the nucleus. Okay, already I told you that represents the radial wave function. Okay, the distance from the nucleus where the probability of the electrons are maximum, that explained by the radial distribution function. Radial distribution function. Okay, we can find out the probability of electron maximum with the distance from the nucleus. Okay, we can find out the probability of electron maximum. Maximum means not exactly 95% probability we can find out. Okay, consider a single electron of hydrogen atom. Here, the probability of electron is maximum. Okay, for one s-orbital, you know how many electrons are having maximum in s-orbital? 2 electrons. Okay, when considering hydrogen atom, only 1 electrons are having. Okay, you know the atomic number of hydrogen atomic number 1. So what is electronic configuration for hydrogen? 1s1. Okay, you know hydrogen atom only 1 electrons are having. Only 1 electrons are having for the hydrogen atom. This is the 1s orbital. Okay, the electrons is very closer to the nucleus. Electrons are, this is the 1s orbital. The electrons, you know, this is here, all having the electrons. Okay, the electrons, the nucleus is the positive charge. The electrons are negative charge, you know. The electrons always, the positive charge always attract the negative charge. Okay, opposite charge always attract each other. The same charge always repel each other. Okay, opposite charge attract each other and negative charge repel each other. Okay, for 1s orbital, the electrons are very closer to the nucleus. Okay, 1s electrons, 1s orbital electron, there are 2 electrons. Okay, for hydrogen atom only 1 electron. This electron, it is very closer to the nucleus. We know. Okay, that is R. R means distance from the nucleus and the electrons. Okay, here R is equal to 0. R is equal to 0 means very closer. R is equal to 0. Okay, within the nucleus, no one electrons are having, but around the nucleus, the electron cloud is very maximum cloud of electrons are having. Okay, so when R is equal to 0, the probability of finding electron in a given spherical shell is maximum. Here, more and more dots are having. Okay, every dots are not an electron. Okay, don't imagine these all dots are all electrons. On s orbital, you know only one electron. Okay, the electrons in an orbital, this you know already, the electrons revolve around the nucleus in a very fast manner. With high speed electrons revolve around the nucleus. Okay, so that is the dot way I mentioned. Here these all the maximum probability of electrons. Okay, here having electrons, here also having electron, here also having electron, here also having electron. Okay, maximum probability only I mention in dot. Okay, not having electrons. For 1s orbital, for hydrogen atom only 1 electrons are having in 1s orbital. Okay, understood? So here 1s orbital, remember only 1 electron, but here the all dots are the maximum probability of electrons in all direction. Okay, the 1s orbital, this spherical s orbital, all in spherical in shape. The 1s orbital, the maximum electron are having in all direction. All direction our electrons are having. That is why the s orbital is spherical in shape. This is non-directional. Okay, this is unidirection. Understood? Okay. Then, when we are plotting a graph against the maximum probability of electrons, that is R into R square, R into R square, R is the function of R, the maximum probability of electrons, and R means a distance. Okay, plotting the graph, this 0, 5, 10, 15, all are the positive value, 0.2, 0.4, 0.6. Okay, we get this like graph. Okay, here when distance is decreases, here the distance, okay, this is the distance, this is the maximum probability. Okay, we are plotting the curve. There is between the distance, x-axis we are taking distance, or y-axis we are taking probability of electrons. Okay, here when the distance is 0, that is R is 0 means the probability will be maximum. Probability will be maximum. Okay, when the distance is gradually increase, okay, this is the distance, maximum distance, the maximum probability for the distance is decreases, maximum probability electrons. Okay, when the distance will be increases, the probability gradually decreases. Understood? Okay, for R is equal to 0, 0 means 0.5, 0.4, that area, the maximum probability of electrons maximum. When distance gradually increases, 5, that is the probability maximum decrease. Okay, and distance 10, it will be 0, probability is 0. Okay, so from this graph, we can understand when the distance from the nucleus and the electron will be decreases. When the electrons are very closer to the nucleus, the maximum electrons are having. Okay, when distance increases from the nucleus, the probability decreases. Understood? These are about the oneness orbital of the hydrogen-like atom. Okay, then let us consider the volume. Okay, the volume dV bounded by two spheres of radii and r plus radii r and r plus dr. Okay, let us, we are taking, this is one of the sphere means first one s orbital and next another one s orbital. Okay, we know that here r means distance from the nucleus and the most probability electrons, and then this point, this is dr we are taking. Okay, so it is the volume of sphere. When we are writing the volume of sphere, you know the formula for volume of sphere, what is? V is equal to 4 by 3 pi r cube. Okay, this is the formula for volume of sphere. Okay, in this volume, the maximum probability of electrons, that is we can discuss now. Okay, so V means the volume of sphere. V is equal to 4 pi 3 into pi r cube. When we are differentiating this formula, dV with respect to r. Okay, dV by dr, because r only differ here. Okay, r only the changing variable. Understood? So we are taking dV by dr. When we are differentiating r cube, what will we get? When differentiated d into x power n is equal to n into x power n minus 1. This is the formula. Okay, one of the mathematical formula. So when differentiating 3 r cube, when differentiating r cube, so r cube is equal to 3r into 3 power minus 1. 3r power 3 minus 1. Okay, so we get 3r square. Okay, wow. So when we are applying this 3r square for 3r cube, we get dV by dr is equal to 4 by 3 pi 3r square. Okay, for r cube we can write 3r square. The 3 and 3 we will cut. So finally we get dV is equal to 4 pi r square, and then dr come here. So we get dV is equal to 4 pi r square into dr. Okay, when I multiplying with psi square, we get, when I multiplying this equation with psi square, we get psi square dV is equal to 4 pi square r square into psi square into dr. Okay, so we plot a graph between 4 pi square or 4 pi r square into psi square between r radius. Okay, wow. This 4 pi r square into psi square means the maximum probability of electrons in the given volume of space. 4 pi r square into psi square represents the maximum probability of electrons in the given volume of space. It will be, I take this in the y-axis and r in the x-axis. I plotted the graph Okay. When we are looking the graph, when R is decreases, the probability will be increases. Okay. When we are considering the hydrogen atom, the only one electrons are having. There is already we discussed about the Bohr atom model. R is the distance. Okay. Already we learned about the Bohr atom model. The distance between the nucleus and central metal atom, that is 0.52 Armstrong. Already we studied. This is equal to Bohr's radius. It indicates that the maximum probability of finding electron around the nucleus at this distance. Okay, wow. In hydrogen-like atom, maximum probability of finding electron around the nucleus is at this distance. That is 0.52 Armstrong. Okay. When we are considering the 2s orbital and 3s orbital, when we are looking the 2s orbital here also, you see when R is decreases, the maximum probability of electrons maximum increases, and the distance of R increases, the probability first increases and then after that decreases and come to 0, and then after that particular point it will be maximum, and then R is increases, the probability decreases to 0. Okay, understood? 3s orbital also. Here, when R is decreases, distance decreases, the probability increases, and after that, after certain points, it will be decreases. After that, after certain point, it will be increases, and then after that, it will be decreases, and then after that, it will be increases, and then decreases. Okay. Why? Here, the probability it is 0. Why? Here the two values are probabilities at 0, because this region where the probability density function reduces 0, that is called the nodes. Okay, nodal surface. Okay, very, very important, nodal surface. When we are seeing the shape of the orbital, this is 1s orbital and 2s orbital and 3s orbital. You see here, how many nodes are having? For 2s orbital, only one node are having. Okay, for 3s orbital, how many nodes are having? 2 nodes are having. Okay, wow. Why the node having here? Node means, what is node? The region where this probability density function reduces to 0. Probability density function reduces to 0. That space is called as node or nodal surface or radial node. Okay, when we are looking this shape of the s orbital, 2s orbital, first 1s orbital, and then here the empty space are having. These empty space are called as node. Okay, and we are looking the graph. 1s orbital, here no nodes. Okay, for 2s orbital, only one node is having here. Okay, the particular point, the probability of electrons will be 0. Because why this happening? Because this is the 1s orbital, this is the 2s orbital. Here the electrons probability maximum in the 1s orbital, very closer to the nucleus, and after that particular point, here not having any electrons. After the 2s orbital having the electrons. Okay, because this 1s orbital and 2s orbital, between why this space are having, these nodes are having here, because the electrons, okay, 1s orbital electron and 2s orbital electrons repel each other. Because of the repulsion here, nodes are having. Understood? When we are find out the node, here having one of the formula, that is n minus 1 formula. Okay, there is only ns orbital. There is only this formula for only ns orbital. Ns means for n is equal to 1 means, so 1s, n is equal to 1 means 1 minus 1 is equal to 0. You see this is the 1s orbital, here no nodes, n is equal to 0. Okay, when n is equal to 2, n is equal to 2 means 2 minus 1 is equal to 1 node, only 1 node. For seeing the 2s orbital, here only 1 node having. For 3s orbital, 3 minus 1 is equal to 2 nodes. For 4s orbital, 4 minus 1 is equal to 3 nodes are having. Understood? So what do you mean by node? Node means the region where there is the probability density function reduces to 0. Very, very important. What do you mean by nodal surface or radial node? It means the region where there is probability density function reduces to 0 is called nodal surface. Understood? Okay. I hope all of you understood. Today your assignment, draw the shape of the s orbital, and all of you should draw the s orbital shape like this. Okay, this 1s, 2s, 3s, and draw the graph. Okay, how can you find out the maximum probability with given distance? That is meant by, we get the idea from the graph. Okay, those who are didn't draw the graph and shape, you should draw now. Okay, if you have book, take your book, page number 46, take now. I will mark the questions now, how to draw the s orbital, shape of the s orbital. Take your book now. So today assignment, draw the shape of s orbital with graph. Draw the shape of s orbital with graph. Take your book now. Okay, students, take now radial distribution function. Page number 46. Radial distribution function. Consider a single electron of hydrogen atom in the ground state for which the quantum number are n is equal to 1 and l is equal to 0. That is, it occupies 1s orbital. The plot of r into r square versus r for 1s orbital is given in figure. This shows the maximum probability of electrons. Okay, the graph shows that as the distance between the electron and the nucleus decreases, the probability of finding electron increases. Okay, this graph shows the distance between the nucleus, the electron probability of electrons increases maximum. Okay, at r is equal to 0, the quantity r into r square, that is indicates the probability of electrons, that is maximum. Okay, the maximum value for psi square at the nucleus, that indicates the maximum value for psi square. Okay, however, the probability of finding the electron in a given spherical shell around the nucleus is important. Let us consider the volume dV bounded by two spheres of radii r and r plus r dr. Consider this is the one of the volume of sphere. Two spheres having here. This is the nucleus. This is the first This is the here having the maximum probability of electron, so it will be take or, and this point we taken as the dr. Okay, so volume of sphere formula, you know, V is equal to 4 by 3 pi r cube. So when differentiating this equation, we get dv by dr. Differentiate with respect to r will be changed. Okay, so we are taking r. dv by dr is equal to 4 by 3 pi into 3 r square. Okay, when cancelling 3 into 3, we get dv is equal to 4 pi into r square into dr. When multiplying the psi square with this volume of sphere formula, we get psi square dv is equal to 4 pi r square into psi square into dr. The plot of 4 pi r square psi square versus r is given below. Is the 4 pi r square into pi square psi square, it indicates the probability of electron, and r indicates the distance. Okay, the above plot shows that the maximum probability occurs at a distance 0.52 Armstrong. Okay, 0.52 Armstrong, the electrons are maximum probability. Okay, the distance decreases, the probability increases. This is equal to this value. It is equal to Bohr radius. Already the Bohr described this distance. Okay, and it indicates that the maximum probability of finding electron around the nucleus is at this distance. Okay, up to here you mark. After that, this is the graph also you mark. And then next page, for 2s orbital, as the distance from nucleus or increases, the probability density first increases, reaches a small maximum followed by a sharp decrease to 0, and then increases to another maxima. After that, it decreases to 0. Okay, first the probability density when distance from the nucleus or increases, the probability density first increase and then suddenly decrease to 0, then increase to another maxima. After that, it decreases to 0. Okay, the region where there is probability density function reduces to 0 is called nodal surface or radial node. Okay, this region are called nodal surface or radial node. In general, it has been found that ns orbital has n-1 nodes. For ns orbital, n-1 nodes are having. In other words, number of radial nodes for 2s orbital is 1. For 3s orbital, it is 2, and so on. Up to here, you mark. After that, angular distribution function. The variation of the probability of locating the electron on a sphere with a nucleus is at each center depends upon the azimuthal quantum number of the orbital in which the electron is present. Okay. Probability distribution also depend upon the azimuthal quantum number. For 1s orbital, azimuthal quantum number L is equal to 0 and M is equal to 0. Okay, so here we are taking two sphere, the F into theta and G into phi. Okay, that depends upon the theta, depends upon the, already I explained. It is the angle of y and r. Okay, angle between y and r, and g half, it is the g phi, it is the angle between x axis and r. Okay, already I explained that the value of f theta is equal to 1 by root 2, and value of g phi is equal to 1 by root 2 into pi. Okay, when we are multiplying these two, okay, but this is the, when we are multiplying these two, we get root 2 into root 2, we get 2. So finally we get the angular distribution is equal to 1 by 2 into root pi. Okay, it is independent of the angle theta and xi in the pi. Okay, so it indicates it is independent, S orbital independent of the angle theta and phi. Hence the probability of finding electron is independent of the direction from the nucleus. Okay, so angular azimuthal quantum number or angular distribution function indicates the direction. Okay, so the s orbital, we know S orbital, the probability of electrons It maximum in all direction maximum. Okay, so the shape of the s orbital is spherical, hence the shape of the s orbital is spherical. Up to here your mark. Okay, this is all the shape of the s orbital. Okay, this is the 1s orbital, 2s orbital, 3s orbital. 1s orbital, no node, and 2s orbital, only one node. 3s orbital, two nodes are having. Understood? Okay, thank you.